Our next section is about properties involving quotients. So, if you remember from previous classes that you've had, I'm hoping that you remember that a quotient has to do with division. So, this is a division thing. If you look back at the previous section, all of our rules, or most of our rules, had stuff about products which had to do with multiplication. So, when we have two things with the same base being divided, what you're going to do is you're going to keep the base the same. It's still going to be a, and you're going to subtract your exponents. So for our examples, I would like you to simplify. As with the previous section, you don't need to solve them. And if you feel good already, you can just go ahead and work these problems out without paying attention to me. But it's up to you. So, for number 1, we have 6 to the 8 over 6 to the 3rd. What we're going to do is we're going to change that to 6 to the 5th. We subtract our exponents. You don't need to write that middle step in unless you want to. But that's all we do for that one. So I'm going to give you guys a few to do on your own. So for number 2, you are going to keep the base the same. It's still 4. Subtract your exponent. 7 minus 2 is 5. That's my answer for that one. 3, just be careful with your negatives. Keep the base the same. It's still going to be negative 2. 5 minus 2 is 3. And that's all I get for that one. So we have a few other types of problems. You just might see a few things that involve more than one rule. So some of these are going to involve things that we did in the previous section. So then for number 4, if you think you can do it, go ahead and pause and try it. Otherwise, go ahead and just watch. So for that problem, what we're going to do is we're going to start by putting together the things in the numerator of our fraction, which means you keep your bases of 4, you add your exponents, 2 plus 8 is 10, then you end up getting something that's really similar to what you had in the first 3 problems. So your final answer is going to be what you get when you subtract your exponents, so you're going to get 4 to the 3rd power. So one more type of problem, and then we're going to go on to another rule. So this is a special type of problem. It confuses a lot of people because not only does it involve fractions, but it also involves variables. So just be careful about that. So we have 1 over y to the 9th times y to the 12th. In general, when you're working with fractions and you're multiplying, you have to multiply straight across. This is no exception. The only thing about this problem is that y to the 12th has no denominator. So what we're going to do is we're going to write it over 1. Now you're going to multiply straight across. You end up getting 1 times y to the 12th. Gives you y to the 12th. Y to the 9th times 1 is y to the 9th. You now are going to subtract your exponents. When you do that, you get y to the 3rd power. I'll actually give you guys one more that's like this, just to make sure you're okay with it. Go ahead, pause, try this one on your own. So for this one, you should have gotten that you ended up with x to the 5th over x squared. you get x to the third for that one. So this next rule, it's called the power of a quotient rule. It's actually really similar to another one we had in the previous section. What you're going to do with this is when you have two things being divided and you have an exponent, you can actually take that exponent, distribute it to everything in the parentheses. You end up just getting something nice like that. So I'll give you a few examples to try. So go ahead and try these. For number 7, we're just going to get 3 to the 5th over 8 to the 5th. To be honest, on this one, when you don't have any variables, I'm fine if you just leave them with the exponents the way they are. This would take a long time to multiply out. It's not impossible, but it's long, so I'm happy if you just leave it like that. On number 8, similar idea, we get 3 to the 2nd over x to the 2nd, or x squared. For that one, go ahead and multiply out the 3 to the 2nd. We know it's 3 times 3, which gives us 9. So that's my answer for that one. So now I'm going to give you just a few more that involve several different properties. So these ones are going to get a little bit harder. They are going to involve some stuff from the previous section. You will find that there are several ways to solve these problems. If you find another way that you like better and you get the same answer, that is totally okay. Feel free, if you find something like that, by the way, to show it to me tomorrow in class, because there's a lot of really good ways to do these problems, and it's your choice if you find another way that works better for you. So for number 9 and 10, if you want to try these on your own, you can. So if you do, pause it. If not, I'm going to go ahead and do it right now. So I'm going to take this 3 exponent, distribute it to everything in the parentheses, including the 2. So don't lose that 2. I get 2 to the 3rd. Y to the 7 to the 3rd gives me y to the 21st. Don't forget that you're multiplying exponents. Once again, multiplying exponents is over y to the 15th. So then I now have a few more steps to go. The first one is this 2 to the 3rd. That I can actually change to 8. My second step is that I have these two y's that are written as a fraction, as a quotient. So what I can do is I can keep my 8 there, but take the two y's and subtract my exponents. When I do that, I end up getting 21 minus 15 is 6, and that's my answer for number 9. On number 10, this is another one there's several ways to do. In my opinion, the easiest way to do this one is to take this negative and keep it up with the 3. I think it's easier if you think of the 3 as being negative rather than the entire problem. By the way, the wrong way to do this would be to make the 3 and the y negative, so just make sure you don't do that. So what we're going to do on this one is we're going to start by doing negative 3 to the 3rd over y squared to the 3rd, so I'm distributing this exponent to everything. Y squared to the 3rd means I have to multiply my exponents. So the y to the 6 stays as it is. The negative 3 to the 3rd, I'd like you to simplify that. So 3 to the 3rd is actually 27, and it's going to be negative. If you want, by the way, feel free to work that out on the side. Negative 3 times negative 3 times negative 3. Go for it if you want to. Otherwise, I recommend that you memorize that 3 to the 3rd is 27. Either way is okay with me, though. Our next problem, I'm generally only going to do with the honors class. However, The CP class might have this as a bonus, so feel free to pay attention if you're in the CP class. It's not going to hurt you, definitely. So there's a few ways to do this problem. I'm going to show you my favorite way to do it. So I always like to start out by looking to see if there's anything I can simplify. I have two fractions being multiplied. If I can simplify either of the two fractions, it's a good, easy way to start. What I always like to do is I like to look at my fraction, group together anything that's like terms. So that 4 and that 16, they are actually like terms. They're both numbers. These two m's, also like terms. And here my two n's are also like terms. So I can actually try to simplify those things. So 4 over 16, just be careful on that. A lot of people like to say, oh yeah, it's 4, but actually it's the same thing. If you were to simplify that as a fraction, it's the same thing as 1/4. So m to the 10th over m to the 4th, that is going to give me m to the 6th. Whenever I subtract my exponents, by the way, if I subtract them, I always start with whatever the higher number is and subtract from there. We'll do more examples with that later on, by the way. So if you're confused about that, it's okay. You'll get more of that later. So then the end of the second just stays there. We're not going to do anything with it. In the other fraction, m to the second, can't do anything with that. 25, we can't do anything with that. However, these n's we can do something with. So I have n to the 8th over n to the 2nd. I can simplify that to n to the 6th. Now I am going to multiply straight across. So remember, with fractions, you multiply straight across. I'm going to start with my denominator because it's easier to deal with. 4 times 25 I know is 100. So now I need to combine my like terms. So I'm going to start with, and I can only multiply my like terms is what I mean to say. I'm going to start with my m's. They have the same base, so I am allowed to put them together. Unfortunately, you can't put together m's and n's. It's not going to work. They're different variables, so you can't really do anything with them. So multiplying across, m to the 6th times m to the 2nd is going to give me m to the 8th. Same thing, multiplying across, n to the 2nd times n to the 6th is going to give me n to the 8th. So actually what I have right there is my answer. M to the 8th times n to the 8th all over 100.